Hello guys, what's up? Welcome to our channel. Here in this video, I am going to show you how exactly do we draw the NPN and PNP transistor in common base configuration, common emitter configuration, and common collector configuration. I'll show you the most easy way, the way I find it easy to draw them. So I hope that it might be helpful to you. So let's get started. Before we jump into learning both PNP and NPN transistor, it is better that you learn one of those at first, because there is not much difference in between NP and PNP transistor diagrams, except for the direction of the current flow and the voltage source. So here we're gonna know or learn the circuit diagrams of common base configuration, common collector configuration, and common emitter configuration of both NPN and PNP transistor. I'll show you the difference in between NPN and PNP transistor diagrams at last. But first of all, let's jump into the drawing of common base configuration of NPN transistor. So there is nothing much that we should do. First of all, we're going to draw a circle like I've drawn, a chord, and through the middle of the chord I've drawn a straight line, and here through this point I've drawn another straight line, and through this point I've drawn another straight line. Except for that, I have shown an arrow here, and whichever book you go through, wherever you encounter this transistor diagram, you'll always come to know that an arrow is given. But in case of NPN transistor, arrow is given outwards, and this represents that it is emitter. So I've denoted E here, I've written E here. Base is always in the middle, so this is base, and collector, the one which is left, is collector. Now after this, I will draw straight line from here, leaving a little gap, and I'll do the same on the other side. I am going to draw one resistor over here, like this, another resistor here, right like this. Since it is emitter and this tends to be the emitter side, this resistor will be named as RE. And since this is the collector side, this resistor will be named as RC. And now, according to KCL, Kirchhoff's current law, for a junction, here this is the junction, for a junction all the outgoing current is equal to all the incoming currents. That means in case of transistor, the outgoing current is IE. That means the current that passes through emitter is the only outgoing current, and the ingoing currents are IB here and IC here. For this junction, these two are the incoming currents, and this is the outgoing current. So now the gap left here, it has to be filled with voltage supply. So supply voltage should be drawn here. But before that, I should make you clear about the fact or the process, how it is filled. So you'll have to draw battery or potentials here with its positive and negative terminal. But how exactly is the negative and positive terminal is given? Let me show you how. So since the current is going from over here, IC is passing this way, to make it easily understandable, I'll say you that if the current is going from here, is being supplied from over here, it is going inside, then give it a positive terminal, and the left is negative terminal itself. And now in this case, you can see that the emitter current is coming outward, so it is coming this way. That means it is going to be negative terminal, because it is not passing from here, but it is coming towards this point. That means give it a negative terminal, and the rest is positive terminal. So it will make it easier to understand and remember. Okay, now the final thing you have to do is connect something here, right like this, before the resistor and before the potential. This is voltmeter, and you'll name it like this. The thing that is connected to the positive terminal, it is collector, IC. So C is mentioned before, and then you'll write B because the negative terminal is connected to the base. And here the positive terminal is connected to the base, so we'll write B first. And then the negative terminal is connected to emitter, so I'll write E afterwards. So this is the final figure. Let me write it. This figure is of NPN transistor. NPN transistor, common base configuration. Now let's get into PNP transistor. There is not much difference, as I've already said, I've already mentioned. Let's see what the difference is. We'll have to repeat the same process. First of all, draw a circle and then draw a chord and give it a V shape. And draw two straight lines and then one straight line downwards. Exactly like this. But in case of PNP transistor, the only difference you'll find is the switch in between positive and negative terminal of the voltage supply and the direction of current that reverses. That means here in case of emitter, the emitter current comes inward in case of PNP transistor. So this is emitter, this is base in the middle, and this is collector, exactly like before. But the only difference is the direction of current. That means IC will go outward and so will IB. So here I'll leave a gap and I'll draw the resistor. I'll do the same over here too. I'll draw a resistor and I'll leave a gap over here. Now for the potentials, here you can see a positive terminal, so I'll draw a negative terminal because, as I've already mentioned, there is a switch in between the terminals, positive and negative terminal. So here this is positive terminal, so I made this negative, and here it is negative terminal, so I'll make it positive. And so goes with this part as well. This will be positive and this will be negative. And now IC will come this way, and IE will go this way. This is RE and this is RC. And I'll be setting this thing up. And for the naming, since the positive terminal is connected to emitter, it will be E. And negative terminal is connected to the base, so it will be B. So same thing goes here. Since positive terminal is connected to base, it will be VB first, and then it is connected with negative terminal is connected with collector, so it will be VBC. So it is exactly the opposite, and there is not much difference, as I've already mentioned. So you need to know at least one of this. You need to understand at least one of the NPN or PNP transistor, and you'll know the rest simply this way. So here I will write figure PNP transistor. This is common base configuration. Common base configuration. And for the input and output characteristics, for the study of input and output characteristic of common base configuration or whatever configuration it is, the thing that I forgot to mention is that here I've made this a resistor. I've run this resistor in emitter side and collector side as well, but I did not draw any resistor in the base side, because if it is common base configuration, then you should not be drawing the resistor in the base in the baseline. So except for that other two parts, you'll have to draw these resistors. Now that we've completed common base configuration of NPN and PNP transistor, the circuit diagrams, we'll move to common emitter configuration. And now for common emitter configuration, I would like to change the direction of this V inside the circle like this. I'll draw a circle. I'll draw a curve on the left side. And I will draw this V shape like this. And as I did earlier, I did earlier, I'd like to draw one horizontal line from here. And since I've already mentioned the middle part is always a base, so I'll label it as B. And I'll go downwards. Because this is common emitter circuit, I've drawn this light in the middle. The vertical lines, I've denoted them as the common thing. That means in the previous picture or previous diagram, it was base in this vertical line actually represented the base in the previous diagram, and here this represents the emitter this time because we're drawing common emitter circuit. So I'll extend it a little bit and I'll draw another straight line from here. So this time it is common emitter circuit, and I've mentioned that in case of NPN transistor you'll notice one arrow which is going outward. So this is emitter and this is collector. So the thing that is common is emitter. So we don't have any resistors over here, but we'll have to draw a resistor in case of base and in case of collector. So we'll leave a gap over here for the voltage supply, exactly as before. And now that we've done it, the outgoing current is of emitter, so incoming currents are of base and collector, right like this. So it is going through this point, so this tends to be the positive terminal because it is passing from here, and here is the negative terminal. And in case of this figure, IB is going through here, so this tends to be the positive terminal and this the negative terminal. Okay, so something is required in order to measure the voltage, exactly like this. Okay, let me label it as V, and since I've already told you the way to actually denote it, so here the positive terminal is connected to the collector thing, so we better write C at first, and then the negative one is connected to E, so we'll write E over here. Here the positive terminal is connected to the base, so I'll write B at first, and then the negative is connected to emitter, so I'll write B, VBE over here. So this is it. So this is figure of NPN transistor, and this is common emitter configuration. Common emitter configuration. Okay, so exactly the reverse process goes on with PNP transistor as we've done in common base configuration. So I'll show you how. I'll draw a circle, a chord, a V shape. Then you'll go with this, right like this. Leave a gap over here. And then a resistor over here. Yeah, straight line. A resistor over here as well. A gap. So this resistor, okay, here the emitter current goes inward in case of PNP transistor, exactly the opposite, because here the current is going outward, here the current goes inward. So this is emitter, of course, base is always in the middle, so this is base, and here she is the collector. Now this resistor, because it belongs to the base area, it can be represented as RB, and this resistor belongs to the collector area, so it should be written RC, labeled as RC. Okay, now in this figure, the positive terminal is here, so this tends to be the negative terminal in case of PNP transistor. Exactly the opposite happens. And in case of this figure, here is the positive terminal, so I'll just switch the terminals. It is that easy. Okay, so now then we'll have to change the arrow because IC is going outward here, so IC will come inward. And in case of this figure, IB is going outward here, so IB will come inward. So IE will go upward, and this is it. In case of okay, so this is the base side. We'll label this voltage source as VVB, and this is collector side, so we'll label this as VCC. So we'll draw a voltmeter here and here. So this will be labeled as VEB because the positive terminal is connected to emitter. So I wrote E here, and the base negative terminal is connected to the base, so I will write B later on. Same goes with this. So first of all, the positive terminal is connected to E, emitter, and the negative terminal is connected to C, the collector. And there you go. And this is the figure of PNP transistor. And it is common emitter configuration, of course. So here you see. Now that we've completed both common base configuration and common emitter configuration on both NPN and PNP transistor, the only thing we're left with is common collector configuration. There's a little difference, a slight difference in this figure, so you better watch it and listen to it carefully. So we're going to draw it. First of all, the same circle, same card, same V shape. But this time, we're going to make this part the emitter. So for NPN transistor, the current goes outward, so the arrow goes outward. I'm going to draw one horizontal line here, one vertical line here. This tends to be collector because it is common collector circuit. And this tends to be the emitter. Here is the arrow, so this tends to be the emitter. And here it is the base. I will draw one resistor over here, as I always draw. And I'll leave a gap over here. I'll leave a gap over here as well. And draw a resistor here too. And since this is the area of base, it is RB, and this is the area of emitter, so this is RE. And now, here the emitter current goes outward, that means the base current IB comes inward, and the collector current IC goes inward as well. So in this case, IE comes this direction. So here, the supply for our IC is being made from over here, and the IE is coming this way. This tends to be the negative terminal, and this the positive terminal. And here is the difference. We generally assume that since IB is going from here, we'll draw a positive terminal over here, but it is not correct in case of collector circuit, common collector circuit. We follow the same process in case of common base and common emitter configuration, but in this case there's a difference. Although we assume that IB goes from here, we can't make it the positive terminal. Here is the negative terminal and here is the positive terminal, and we will assume that IC is coming this way. Sorry, IC is going from this way, so this tends to be the positive terminal. And for naming, since this is the base area, we'll label it as VBB. And since this is emitter area, we'll label this as VEE. And we'll connect something over here and here as well. And this is V. So here the positive terminal is connected to collector, so it is VC, and negative is, so I've labeled it. And in case of this one, the positive terminal is connected to collector, so it is VC, and the negative terminal is connected to emitter, so it is VCE. So here we go, figure and PN transistor, common collector circuit, collector configuration. Now for PNP transistor, we'll follow the same thing, just reverse everything. Here we go. Here the emitter current is going outward, so in case of PNP transistor, the emitter current will come inward, and except for that everything must be same. I'll draw a resistor over here, and this tends to be the collector line, and I'll leave a gap over here, and here B. This is for base, this is for emitter, and this is for collector. And here I draw another resistor, leaving a gap over here. And in this figure, IB is going inward, so in this case IB will be going outward, and so will IC. IC is going outwards as well. So here it is, the positive terminal is over here, so let's switch it, the negative here and positive here. And let's switch this as well, positive here and negative here. So this will be labeled as VBB, and VE as above, same as above, and IE will be going this way, and there are not much difference. Now we'll add final thing to it. This is V and this is V2, but this tends to be exactly the opposite one. That means here it is VCE, so it is VEC, and here it is VCB, so it is VBC. So that is all about it. PNP transistor with common collector configuration. Common collector configuration. So this is all we had for this video. Thank you so much for watching this video. Do like, share and subscribe. And for more other videos like this, please subscribe and hit the bell icon. Thank you for watching our video. Goodbye.